I will have the pleasure today to talk to you about predicting the future. And obviously in terms of software development, not some obscure art. So when thinking about predicting the future, I really like the quote from Troy McGinnis. So whatever tool, whatever technique you pick, it doesn't necessarily need to be perfect. It just needs to be slightly better or slightly cheaper of what we are doing now. So for us, it was a pretty easy choice. We didn't have any systematic approach to forecasting, so there was nothing that we were kind of competing against. But we had some clues that we wanted to base our decision on. We ended up with picking statistical forecasting using the Monte Carlo method because we wanted our tool to be based on data, to be easily implementable and explainable to people. And this technique is based on math, but it's not a very complicated math. It's really easy to understand. It's really easy to follow how it works. And you can reapply and reapply and reapply and refine the way you use it. So this was our method of choice. For those of you who are, how many of you do know what statistical forecasting using Monte Carlo method is? Okay, a few of you. For those of you who don't or know a little, just like a very, very brief walkthrough. So imagine that those numbers on the screen represent your throughput. So represent the number of items you are delivering weekly. And now imagine that I will take each of those numbers, put them on a piece of paper, and put all of them in a box. And if I want to predict the future, so predict how much I can deliver in the next 6 weeks, I will draw a card from the box, write the number down, put the card back into the box, and draw again. And I will do it 6 times because I want to predict the number of items delivered in 6 weeks. And I will call the trial. I can have multiple trials like that. So I can have multiple versions of what can we deliver in 6 weeks. I guess some of you are operating with things like burn-up charts or burn-down charts. So using linear regression, some of you probably try to predict the future as well. So when you are doing statistical forecasting using Monte Carlo method, you will have multiple possible futures. So instead of having one burn-up chart, if I run the simulation over and over again, I'm talking about hundreds or thousands of times, I will have many, many burn-up charts. So, and it will start somewhere and end somewhere in the future, and everything that's in the between is my cone of uncertainty. But because I've done it enough times, I can mimic the distribution of my throughput. So I don't know it exactly, and the good thing is I don't need to know it because I have good enough approximation. So instead of providing people with an answer like, well, I think it's going to be that date, I can provide them with much better answer. So it's not only a single point of data, but I can provide you with, well, if you want me to be like 85% confident, it's going to be here. If you want me to be 95% confident, well, it's going to be here. So instead of asking me, when can we deliver the project, well, give me what the confidence level you're after. So what brought us there? What allowed us to get to a point where we could have been using the method in a way that was sustainable? And I will be talking about kind of obvious stuff, but it all boiled down to obvious stuff. So first, you need to know what you know. So we are all measuring different things: cycle time, lead time, velocity, story points, throughput, failure demand. Probably you can name much more than I've just numbered. And some of them you can trust, some of them, well, it depends. My experience is that some of the metrics are flawed because, for example, there is a KPI, so there is an incentive behind a metric. So people will game the system in order to be compliant with the KPI. Or a metric will be flawed because people constantly forget to update the starting date on a particular item. So looking at different things that we could have taken, we picked throughput because this is probably, for me, the easiest metric to measure. You just look at your done column in a given cadence, and you count the number of items that reached the done column. So we picked throughput, we picked cadence, we wanted to account our throughput fortnightly. We knew our scope, or rather scopes, because our project was divided into milestones, so we knew the subscopes. We also knew something that people call split rate, or, well, we didn't know it, but we were capable of counting it backwards. So when I say split rate, for the sake of this presentation, I mean that there is like a mismatch on the granularity of the items you have in the backlog and items that reach your done column. So in our backlog, we had features or epics or whatever you call them, and before they reached the done column, they become sub-features, so some smaller chunks of work, or MVPs, or whatever you want to call those. So we needed to somehow determine and calculate what's the ratio. Is it like 1 to 3, 1 to 5, 1 to 7? And again, you can assess the ratio, or you can actually mimic the distribution applying the Monte Carlo method again. Second step, well, you need to know what you don't know. So what's not in your data, and you are not able to kind of account it backwards. So we didn't know anything about the sizing of the items. And as it goes with the sizing activity, well, you cannot apply it backwards because it's a different size. So we didn't know whether size mattered, but well, for us, we didn't have the data anyway. We didn't have the type either, so whether it was a business feature, a bug fix, so what's the origin, what's the kind of nature of the work. We didn't know anything, well, close to anything, about the fungibility of our teams. So fungibility is the ability of any given team in a company to work on any given item from the backlog. So if you are working in a company that consists of 3 teams and 1 single product, you can probably strive for 100% fungibility. We had 12 business domain streams. We had 30 teams, so-so. And it's kind of a myth to strive for 100% fungibility. But we didn't actually know who can exactly work on what. So we ended up with a rule of thumb that we are going to trust, to hope, and later or maybe validate, by trust and hope, that what's going to happen in the future will be close enough in nature to what happened in the past, in terms of size, in terms of type, in terms of fungibility. And the third step, know what you can agree on. So it's neither in the data nor outside of the data, but those are calls that you kind of need to make in order to start the forecast. And there were probably more assumptions than the ones that I'm going to name today. I will name just 3. So first is no scope creep. That's a fallacy, isn't it? So what I mean by that is not that there will that scope creep will not happen, but some of that we already had accounted in the split rate, so that we'll be kind of adding sub-features as we go. And when it comes to operating with the backlog, the agreement was that there is no free lunch. You add something, you need to remove something. Second agreement was around multiple upstreams, so multiple streams of work coming to the backlog. We knew our business features. We also knew that there are some technical improvements, but as it goes with technical improvements, you don't know all of them up front. some of them will occur. So what we did instead was we calculated the ratio of technical improvements to business features for the last 6 months, and we trusted that it will be similar in the future. So having 15% of technical improvements, we needed to scratch 50% of the backlog to kind of preserve the room for technical improvements to come. And second nature of work was totally unknown to us because we have just released the first version of the product, so we knew that there will be some features based on the customer feedback. And we had no idea how to assess that, so we took a different approach. We decided that for the next 3 months, we'll restrict the number of features coming from customer feedback to 1 per customer per quarter. Sorry, 1 per customer per month. So it gave us another number that we could have validated later on, but it allowed us to start. So after having the data, after making those calls, we are finally capable of running the simulation. And I don't know what happened in your situations for those of you who used that kind of approach, but the first thing that happens is that, well, you finally see what's ahead of you. And in most cases, it's not a very uplifting perspective. So we had much more planned in the backlog that we could have met by the date that was set by our business stakeholders. But at least you are now capable of talking data to people. And this is really fun part when it comes to using that kind of approach. Because, well, data is there. It's hardly debatable that the throughput is as it is. We can still check whether we counted it correctly, but it is as it is. And when it comes to assumptions, well, we have ours. If you have better assumptions, let's negotiate. We can have a conversation about technical improvements. We can have a conversation about features coming from customers. And we can rerun the simulation. So if you have better assumptions, fine, let's use your assumptions, and let's try to see where it gets us. If you don't like our likelihood for the date, well, give us the likelihood you are after. We can negotiate. We can run the simulation again. And we also started providing our business people with guidance how to use the model themselves, and also started having different conversation about data, because they trusted how we operated. It also gave us the opportunity to validate the assumptions after some time. So after a quarter, we realized that actually the customer feedback is not happening yet. So, well, maybe we have a different problem to solve, but definitely we can be safe on our restrictions. But number of technical improvements actually went up, and we needed to adapt the model. We needed to make a call whether we want to allow all of them, or maybe we want to scratch some of them, or if we need to remove more business features. So it allowed us to refine the way we work, not only refine the model, but also refine the way we work organizationally. So some initiatives around protecting the flow happened, some initiatives around reducing wait time, removing bottlenecks. Those things started to happen. Managers started paying attention to that to help team actually improve the global throughput. And obviously, it's not only about increasing the speed of work, it's also about negotiating what's there. So scoping and prioritization conversations were also at the table. And actually, some of the business features were removed in order to move the date closer to the desired one. And yet another gain was a mindset shift that happened across the product group in our company. So as Tomek said during the introduction, it was like a 1.5-year journey, and we were starting with people who were talking about linear regression and using averages and gathering a bunch of experts in a room and guesstimating the date. And we ended up with people talking about flow efficiency, percentiles, distributions, and actually understanding what they are talking, not repeating some agile coaches, but actually pitching the same stuff to others. And last but not least, probably the most important bit about statistical forecasting is the ability and the gain you get when you reforecast. So you can have the same model, you can refine it, and you can run it over and over again. So the method is not only easy, it gets easier with every single run. It's not only cheap, because it's just numbers and calculation, it gets cheaper with every single run. So in order to be able to trust your data and forecast and predict the future, you need to know what you know. You need to know what you don't know. And you need to make some calls and validate them later on. Thank you.